Right, okay. Today I'm going to discuss the answers of our first model paper, which is put as number 1. This is actually for the grade 12 new students. Okay, right. Let's move into the first question. The first question we have been asked to convert those decimal numbers into the fractions. Okay, now let's see how can it be done. First question is 0.6 dot. This is a recurring decimal number. Now we have to convert this recurring decimal number into a fraction. Okay, right. Let's take this decimal number first as x. So x equals 0.6 dot. Now we can rewrite this decimal number like this. 0.6666 is going on forever like that. Just take this as your first equation. Right. Now we have to multiply this equation by 10. Then you can have like this one. First equation multiplied by 10. Then 10 of x equal 6.6666. This is your second equation. Now subtract second equation from the first one. Then you can add second equation minus first equation. You will get 9 times x equal 6. If you subtract, these decimal numbers will cancel with each other, right? Okay. Now isolate x. Then you can get x equal 6 over 9. You can simplify this fraction by dividing by 3, both numerator and denominator. Then you will get 2 over 3. That is the equal fraction which is equal to this decimal number. Likewise, you can easily solve it, or you can easily convert those decimal number into a fraction. Okay, now let's take the next question. In that question, 2.34.7 dot. This is also a recurring decimal number. Now you have to convert this into a fraction. Let's take like the first one. Just take this decimal number as x. Then x equal this one. We can rewrite this decimal number like that. X equal 2.3474747. Like this is the recurring part. 4 dot and 7 dot is recurring like that forever, right? This is the first equation, right? Now we have to multiply this equation by 100. Then you can get this kind of, we have to multiply by 10. Then 10 times 1. That is 10 times x equal 23.474747 is going on like that forever, right? Now again, what I doing is again I multiply the second equation by 100. Right? Then look at the result by 100. And then you will get 1000 times x equal 2347.4747. Likewise, it's going on forever. Right. Now subtract the third equation from the second equation. You will have this kind of result. Then 1000x minus 10x, that means 990x equal. Look at this side. Those decimal cancel with each other. If you look at, if you subtract 2347 by minus 23, you will get like this. You will get 4, then 2, then 23, 24. Right. You will get that kind of result. Now isolate x. Then x is equal to 2324 over 990. If you like, you can divide by 2 and you can simplify the answer, or you can leave it like that. Okay? So the fraction which is equal to this decimal number, this recurring decimal number is this. This is your answer. Okay, now let's move on to the second question. In the second question, you have been asked, you have given a fraction like that. You can see denominator is not a rational number. You see rational, so you have to rationalize this denominator and simplify the fraction. Okay. Now I have been asked to rationalize the denominator and simplify this fraction. Right. Now you know if you want to rationalize this denominator, you have to multiply the denominator by its conjugate. Okay. Now I'm doing that. So you can write the conjugate of this denominator, that is 2 times root 2 plus 1, gain 2 times root 2 plus 1. Right? That is the conjugate of denominator, right? Then you will get, if you look at the numerator, 4 times root 2 plus 2 over, look at this one, right? You know that a minus b times a plus b is equal a squared minus b squared. Likewise, we can write 2 times minus 2 times 2 minus 1 square, like that, right? Then we can write again 4 times root 2 plus 2 over, what is the 2 times root 2 squared? What is the answer? That means 8 minus 1. Again, finally, 4 times root 2 plus 2 divided by 7. That is our final answer. So, after we rationalize the denominator, we can get this answer, right? We can't actually simplify this any further. So, this is our final answer. Right, okay, now let's move into our third question. In third question, you have been asked to find domain and range of this given function. The function is given f of x equal x squared plus 7. Now we have to find the domain and range of this function. First, we find the domain of this function. Now, I rewrite this function as y equal x squared plus 7. Now you know that x is our independent variable and y is our dependent variable, right? Now think about the x, our independent variable. Think about the values, think about the input values that we can put into x. Now if you think, you can see there is no restriction. You can put any value for your x. So we can say that, so our domain is real numbers. There is no any restriction. You can put any value for your x. So I can write domain is equal, we can say real numbers. You can put any real numbers into x. There's no restriction. So our domain is all the real numbers. So now let's see the our dependent variable. Now we find the range of this function. For that you have to isolate x. I do that like this. Y minus 7 is x squared. Then x squared equal y minus 7. X equal plus or minus root y minus 7. We can isolate x like that. Now think about this part. You can see y minus 7 inside the root. Now you know this part y minus 7 should not negative. It can't get a negative value. It must be always positive or 0. So I can write y minus 7 should be greater than or equal to 0. That means y is greater than or equal 10. That means our range, I can write our range like that. That means our range close interval 7, open interval plus infinity. That means our range can get to 7 to plus infinity. Those kind of values can in the we can say that range is close interval 7 to plus infinity. Right? Those are the values for our range, and this is our domain. Right? Likewise, we can find the domain and range of that function. Right. Okay, the fourth question. In the fourth question, you have been asked to divide this polynomial by this one using the long division method. Okay, right. Using the long division method, now we find the quotient and the remainder when we divide this polynomial by this polynomial. Right. Let's start. First, consider these two terms. You know what is the procedure. So I will just divide these two polynomials. Right. If you look at the these two terms, I can write 4x squared. That means here 4x to the power 4 plus 4x squared. Then we subtract these two polynomials each other. These two terms will cancel each other. Right. Then I can write minus 2x cubed minus 4x squared minus 3x plus 1. Then consider this term and again this term. Now we have to multiply this term to get this term by minus 2 times x. That means minus 2x cubed minus 2x. Right. Now subtract again these polynomials. Then these two terms will cancel. Minus 4 is squared. Here minus 3x plus 2x, that means minus x plus 1. Again consider the minus 4 times x squared, that means minus, we have to multiply minus 4 x squared, then minus 4 x squared minus 4. Again these two terms will cancel each other, then minus 4 plus 5. This is your remainder. So I can finally write 4x to the power 4 minus 2 times x to the power 3 minus 3x plus 1 is equal to x squared plus 1, 4x squared minus 2x minus 4 plus 5 minus 1. So this is our quotient and this is our remainder. Like that we can find quotient and remainder using long division method. Okay, now the fifth question. Fifth question is being asked from the remainder theorem, right? Okay. Now we've been asked what is the remainder when 3x squared plus 4x minus 1 is divided by x plus 3. We have been asked to find the remainder when this polynomial is divided by this polynomial. But this time we can't use the long division. We have to use the remainder theorem to find the remainder, right? So that first I rewrite this polynomial as f of x, then f of x equal this one. If you can remember the remainder theorem, in the remainder theorem we say that when f of x is divided by x minus a, remainder is fa. That is our remainder theorem. So we can use that theorem to find the remainder in this question, right? Now f of x is this one, this polynomial, and x plus 3, we divide this f of x by x plus 3. That means if we want to find the remainder, we have to find f minus 3. Look at this one, x minus 1, f of x divided by x minus 3, remainder is fa. That means the value x minus a is equal to 0. If you look at this one, when x plus 3 is equal to 0, x is equal to minus 3. Then we put minus 3 into this polynomial. Then we can get f minus 3 is equal 3 times minus 3 squared plus 4 times minus 3 minus 1. That means here 27. 9 times 3, 27. Here minus 12 minus 1. That means 27 minus 13. That means 14. That's our remainder when 3x squared plus 4x minus 1 is divided by x plus 3. Right, let's go to the sixth question. Sixth question is been asked from the factor theorem. Right, regarding factor theorem. It says that we have shown that x plus 1 is a factor of x cube minus x squared minus x plus 1. Right? I will take this as f of x. So f of x, this one, x plus 1 is another polynomial. We have shown that this is a factor of this polynomial. Right. If you can remember, what is remainder theorem? In remainder theorem that says if f of a equals 0, we can say that x minus a is a factor of f of x. There's actually someone say that this is a special instance of remainder theorem. Actually this is called a factor theorem. Factor theorem is said if f of a equals 0, that means x minus a is a factor of f. Likewise, so what is the converse of factor theorem? Converse of factor theorem. That means if x minus a is a factor of f of x, we can say that f times a equals 0. That is a converse of factor theorem. So factor theorem is if f of a equals 0, we can say x minus a is a factor of fx. The converse of factor theorem, x minus, if it is given that x minus a is a factor of f of x, we can write that if f of times a is equal 0, right? Now look at this question. We have been asked to show that x plus 1 is a factor of f of x. So now we do is, I will write that like this one, right? I will write like this, if x plus 1 is a factor of f of x, what will happen? Right, you can say that then f minus 1 must be equal 0. Right, f of minus 1 must be equal 0 if x plus 1 is a factor of f of x. Let's find out that f minus 1, let's find out what is the value of f times minus 1. If it's equal 0, we can say that so x plus 1 is a factor of f of x. Right. Let's find out what f times minus 1, f of minus 1. Right. We substitute minus 1 to the this x, this is our variable. Then we can write minus x times cube minus x squared minus x plus 1. Again here minus 1, here minus 1, here plus 1 and plus 1. Here minus 2 plus 2, that is equal 0. Right. Now you can see f of minus 1 is equal 0. That means x plus 1 is a factor of f of x. Right. And finally say then since f of minus 1 equals 0, we can say that x plus 1 is a factor of f of x. Right. We can solve that question like that. Right, okay, let's move on to the next question. In next question also we have to find remainder and quotient, but this time we have to use division of algorithm to find quotient and remainder of this problem. Right. We have given that this polynomial, we have been asked that what happened, what is the quotient and remainder when this polynomial is divided by this polynomial. First, if you can remember, what is the division of algorithm? In division of algorithm, we can write division of algorithm like this. Dividend is equal divisor times quotient plus remainder. We say that this is the division of algorithm. Now, we know that how to find the degree of quotient. There is a method to find the degree of quotient. Method is, let's assume that the degree of division is m and the degree of divisor is n. Then what is the degree of the quotient? That's equal to m minus n. So what is the, then again, what is the degree of the remainder? We can say that n minus 1 is the degree of the remainder. Right. This is called the division of algorithm. Now let's put those values into the division of algorithm and find what is the quotient and remainder. Right. So what is the dividend? If you look at these two, this is the dividend. So I will write this first. I write the dividend. That means x squared minus 2x plus 3 is equal to, what is the divisor? Divisor is x minus 1. Now think about the degree of the quotient. What is the degree of quotient? Here is the degree of 2 and here degree is 1. So 2 minus 1 is 1. So the degree of the quotient is 1. So what is the general formula of a degree 1 function? What is the polynomial? What is the degree 1 polynomial? That we can write ax plus 3. Here look at the degree of the variable, most highest power of the variable, that's 1. So this is the general formula of degree 1 polynomial. Right. Plus, and look at the degree of the remainder. If you look at the divisor, degree of the divisor is 1. So 1 minus 1 is 0. That means remainder. Degree of the remainder is 0. That means we can write this as a constant, any constant now. Right. Now we have to find A, B and C. For find A, B and C, we use two methods. First one is by substituting values for the x, we can find A, B and C. The second method is by considering the terms which has the same gradient. Right. Now first I will put x equal 1, then I can find the value of C. Right. Let's put x equal 1 here. 1 minus 2 times 1 plus 3 is equal. Here 1 minus 1 is 0. 0 times ax plus b is 0. So I don't write that. Here there is c. Right. So 3 plus 1 0. 4 minus 2 equals c. So c is equal to. Likewise I can find the remainder. Remainder is equal to 2. Right. Now by considering the terms which has the same degree, I can find A and B. So let's consider the x squared terms. Here the coefficient of x squared is 1. If you look at the right hand side, you can say that x times ax, that means a is squared. So the coefficient of x squared in the right hand side is also a, right? Then I can write a is equal 1, right? Now consider the coefficient of x. In left hand side is this minus 2. In the right hand side you can say x times b, that means b and minus a, right? We know already know the value of a, that minus 2 is equal b minus 1, that means b is equal minus 1. Likewise we can find the values of a, b and c, right? Now we know the quotient and the remainder. I can finally write the quotient. Quotient is equal ax plus b, that means I is equal 1, x minus 1, that is our quotient, and our remainder is equal to 2. Our remainder is equal to 5. Likewise, by using the algorithm of division algorithm, we can find remainder and quotient of these functions. Okay, now, right, let's see the next question. And the next question, it says that the remainder when the polynomial, we have given that a polynomial f of x equal x cubed plus bs squared plus 3x minus 1. This is the polynomial that we have been given. Alright. When this polynomial is divided by x minus 1, remainder is 2. We have given that. Also, when this polynomial is divided by x plus 1, remainder is 3. Those two results has been given for us. Now we have to find a and b using those two results. So, I can use the algorithm of division, or I can use the remainder theorem. I think if you use the remainder theorem, this will be easy, right? So I use the remainder theorem. I write by remainder theorem. By remainder theorem. When f of x is divided by x minus 1, remainder is f1 is equal to. We have given that when f of x divided by x minus 1, remainder is 2, right? Now I rewrite this equation like this. F of 1 is equal to a plus b plus 3 minus 1 is equal to. That means a plus b plus 2 equal to, if you cancel 2, a plus b equals 0. This is my first equation. Or you can write a is equal minus b as your first equation. Right. Now we use the second result. When f of x is divided by x plus 1, remainder is 3. Again, I write when f of x is divided by x plus 1, remainder is f minus 1, that is equal to 3. Now we can use the result and again we can have a similar function. By using those two functions we can find a and b, right? So I can write this as this is also like this: a times minus x cubed plus b times minus s squared plus 3 times minus 1 is equal 3, right? We simplify this equation. Minus a plus b minus 3 minus 1 equal 3. That means minus a plus b, here minus 4 is equal 3, minus a plus b is equal 7. This is my second equation. I will write this is as my first equation. So I can add these two equations and I can find by solving these two equations a and b, right? So 1 plus 2. Let's consider what happened. 1 plus 2. A minus a, those a cancel, then 2b is equal 7. So b is equal 7 over 2. A is equal minus b, I know that from the first equation, so I can write a is equal minus 7 over 2. So those are the two values of a and b, right? After that, after determining the a and b, find the remainder when the polynomial f of x divided by s squared minus 1. Now we have to find the remainder when this f of x, this polynomial, when it is divided by x squared minus 1, right? Let's find that, right? So before that, I write the f of x by substituting those values into this one, right? So substituting the substituting the values for a and b, I can rewrite the f of x like this, right? Now we have to find what happened. What is the remainder when this function is divided by x squared minus 1. Let's say the quotient is psi x and remainder. We only have to find the remainder. For this I use the algorithm of division. If you like, you can use the log division. There's no problem, right? So what is the degree of our remainder? You can see degree of the divisor is 2, so that means 2 minus 1 remainder. Degree of the remainder must be 1, right? So I write ax plus b. So this is my remainder. I have to find a and b to find the remainder. So that before that I simplify this x squared minus 1. You know that x squared minus 1 is equal to x minus 1 plus x plus 1, right? Now we put suitable values, substitute suitable values and find ax plus b, right? First I put x equal 1. What happened when x equal 1? F of 1. F of 1 is equal to minus 7 over 2 plus 7 over 2 plus 3 times 1 minus 1 is equal, here to 0. 0 times psi x means 0. And also we don't have to find the quotient, so we don't have to worry about that. In the right hand side we can say a plus b, right? I simplified it further. That means we can cancel these two terms, and here 2 equal a plus b. I will take this as my first equation. Now let's put x equal minus 1. Right, then what happened? Here minus 7 over 2 minus x cube plus 7 over 2 minus s squared plus 3 times minus 1 minus 1 is equal, here is 0. Don't have to worry about that. A times minus 1 plus b, right? We simplify this further. Here this is a minus value, minus times minus, that means positive. 7 over 2, here again 7 over 2, here minus 3 minus 1 equal minus a plus b. Again look at the simplify. We can simplify this equation like that, right? Here 7 minus 4 equal minus a plus b. That means 3 is equal minus a plus b. Take this as your second equation. By solving these two equations, simultaneous equations, we can find a and b. I add one and second equations. Then 2 plus 3 means 5 is equal. We can cancel a 2b. That means b is equal 5 over 2. Right. Again, by substituting this value for the first equation or the second equation, we can find the value of a. I use the first equation. By using the first equation, I can write 2 is equal a plus b is 5 over 2. That means a is equal 2 minus 5 over 2. That means I can write a is equal minus half. Right. Those are the values of a and b. So finally I can say the remainder. I can write the remainder is equal to a times, a is minus half x plus b is 5 over 2. This is our remainder when this f of x is divided by x squared minus 1. Right. Right, let's move on to the next question. In the next question, we have given that very big polynomial f of x equal x to the power 8 plus 2 x to the power 7 plus a squared plus bx plus c, right? There should be a correction in this one. Is divisible by s squared minus x, here not positive, it must be negative, minus 2 without, remember it said that if we divide this polynomial by this polynomial, there is no remainder. That means it's a factor of this polynomial. Again, there's another help for solve this question. Again, it says that when this polynomial is divided by x plus 1, remainder is minus 8. Those two helps are given to us. So using those two helps, we have to find a, b and c, right? First, for find a, b and c, I use the division of algorithm. First I write the division of algorithm, right? The first f of x, this is our dividend. X to the power 8 plus 2 x to the power 7 plus a squared plus bx plus c is divided by x squared minus 6 minus 2. This is the divisor. So first time factorize this divisor. What is the factors? What are the factors of x squared minus x minus 2, this polynomial? we can write x minus 2 times x plus 1. Those are the factors of this polynomial, right? Now I write these two factors for here, for divisor, right? Then I can write x minus 2 plus x plus 1. This is my divisor. So quotient, I don't need the quotient. I know that remainder is these are the factors of this polynomial, so the remainder is 0. I don't want the quotient here, so I can write my division of algorithm like this. So then I will substitute suitable values for this equation. So first I put x equal 10. What happened when x equal 10? Sorry, 2. Right. Here 2 to the power 8 plus 2x7. That means 2 to the power 7 plus a 2 to the power 4 plus b times 2 with power 2 plus c is equal here 0. Right. Right. We simplify this equation and get another equation. Right. What is 2 to the power 8? That means 2 to the power 8. Right, we know that 2 to the power 8 is 256 plus here again 256 plus 4a plus 2b plus c is equal 0, right? Then I can write 4a plus 2b plus c is equal minus 512. This is my first equation, right? Again I put x equal minus 1. What happened when we put x equal minus 1? Here minus 1 to the power 8, that means plus 1. Here 2 times minus 1 to the power 7, that means minus 2. Here minus to the power minus 1 is squared, that means plus a, here minus b plus c is equal to again 0, right? So again I can write minus 1 plus a minus b plus c is equal 0, a minus b plus c is equal 1. This is my second equation, right? Now the second help, when this polynomial is divided by x plus 1, that should be x minus 1. Yes, that should be x minus 1. Okay, this question is wrong, right? When this f of x divided by f of x is divided by x minus 1, remainder is, we have given that remainder is minus a, right? This is our second help, right? Now I use the remainder theorem. I put f of 1 equal here 1 plus 2 plus a plus b plus c is equal minus a. I can write like this, so I delete these parts, right? So you know that there are two unknown terms a, b and c. At least we want 3 equations to find a, b and c, right? So I already found 2 equations. I already found 2 equations. Now I have to find another one to solve to find a, b and c. So this is my third one, right? I can write 3 plus a plus b plus c is equal minus 6. That means a plus b plus c is equal minus 5. This is my third equation. By solving these 3 equations, I can find what are the values of a, b and c. Right, okay, those are the 2 equations, 3 equations were found, right? Now using those 3 equations, let's find what are the values of a, b and c. For that, first I will add second equation and third equation. Then 2 times a plus c is equal to minus 4. That means a plus c is equal minus 2. I will take this as my fourth equation, right? Then again I will fine. Okay, now then I multiply the second equation by 2, then add the first equation, right? Then 2a plus 4a, that means 6a, 2b minus 2b plus 2b, those terms will cancel. Then 2c plus c, that means 3c is equal, when we divide multiply second equation by 2, 2 minus 512. Right, that means 6 times a plus 3 times c is equal to minus 510. We divide by this by 3, you can get 2 times a plus c is equal minus 170. Right, I will take this as my fifth equation. Right, now let's solve these fourth and fifth equations. For that I subtract fifth equation by fourth equation. Right, that means 2a minus a, that's a, those c will cancel each other. Right, then minus 170 plus 2, that means a is equal to minus 168. I'm not sure about the answers. Let's check the answers again. Okay, right, so a is equal minus 168. Right, that means we can find the value of c. For that I use the fourth equation, a plus c. A is minus 168 plus c is equal minus 2. That means c is equal minus 2 plus 168. C is equal 166. There is the value of c for our equation. Finally, we can find the value of b. For that we can use any equation 1, 2 or 3. I use the second equation. By using second equation, a is equal minus 168 minus b plus c is equal 166 equal 1. That means minus b, here minus 2 is equal 1. So minus b is equal 3. That means b is equal minus 3. Those are the values for A, B and C. Again I am saying that I am not sure about the answers A, B and C. Recheck the answers for this question. Right. Right. Then let's move to our final question. Resolve the following into partial fractions. You have to resolve these fractions into partial fractions. Now just check this fraction is a proper fraction or improper fraction. First you have to check that. If you look at the degree of the numerator, it's 1, degree of the denominator is 2. That means this is a proper fraction. Right, then we can partialize this fraction like this: a over x plus 1 times b plus b over x plus 3. Right, like that we can first partialize this fraction like that. Right, now we have to find a and b. For that I multiplied by this x plus 3 like this. Then x minus 1 is equal a times x plus 3 plus b times x plus 1. Right, now we can substitute the values, or we can by considering the coefficient of equal degree terms, we can find a and b. Right, I consider the degrees of 1 x degree. So here coefficient of x is equal 1, here a plus b. This is my first equation. By considering the constants, we can write minus 1 is equal 3a plus b. This is my second equation. Right, by 1 minus 2, that means 1 minus plus a is equal to 2. A minus 3a means minus 2a. Right, then a is equal minus 1. From the first equation I can write when 1 is equal minus 1 plus b, that means b is equal 2. So those are the values of a and b for our first partial fraction question. Right, now let's check the second question. If you look at the second question, check the denominator, the degree of the denominator and the degree of numerator. You can see that both the degrees are equal to 2. Both degrees are equal. So this is not a proper partial fraction. This is not a proper fraction. This is an improper fraction. Right. When the degrees are equal, you know that you have been told that we put a constant first. That means a plus, then here if you can factorize. You have to factorize the denominator first. I will factorize it first. 3x squared plus 4x plus 7. Right, you have to factorize this. What are the factors? You can write x minus 2, x minus 1. Those are the two factors of this one. Right, then I can partialize this fraction like this: a plus b over x minus 2 plus c over x minus 1. right. Now you have to again the same procedure, x minus 1, x minus, we have to multiply this by this one. Again 3x squared plus 4x plus 7 is equal a times, here I will write that one, x squared minus 3x plus 2 times b times x minus 1 plus c times x minus 2, like that, right. Now you have to consider the coefficient of equal terms. That means if you consider the coefficient of s squared, here left hand side you have 3, in right hand side a, right, then a is equal 3, right. If you consider the terms of x, in left hand side is 4, here 3a plus b plus c, right. So a is equal 3, that means 4 is equal minus 9 plus b plus c, that means b plus c is equal 13. This is my first equation. Then I consider the constants. If we consider constant, there is 7 is equal 2a minus b minus 2c. A is equal 3, that means 7 is equal 7 minus b minus 2c, that means 1 equal minus b minus 2c. b plus 2c is equal minus 1. This is my second equation. By using those 1 and 2 equations, the second equation I can find b and c. Right. For that, I will subtract the second equation from the first equation. That means I can cancel the b. 2c minus c is equal c is equal minus 1 minus 13. That means c is equal minus 14. Right. Then we'll delete this one. I guess this one. Right. Then b minus 14 is equal 13. I use the first equation. That means b is equal 27. Right. Now I found the a, b and c. So those are the values for a, b and c. Okay, let's move to our final question. Final question is this. This is the final partial fraction. Right. If you check the degree of the numerator and denominator, you can see that this is a proper partial fraction. So we can easily factorize or partialize this fraction. We can write a over x minus 3 plus, here look at this part, x squared plus x plus 1. You know that we can't factorize this part, so we have to write this like that, x squared plus x plus 1 over here. We have to put bx plus c for the numerator because we can't factorize this polynomial, right. Then again the same procedure, x minus 3, we multiply this whole x minus 3, x squared plus x plus 1, right. Then x is equal a times x squared plus x plus 1 plus bx plus c times x minus 3. Now I consider the terms of x squared, coefficient of x squared, that means here it's 0, here a plus b, right. This is my first equation. Then consider the coefficient of x, that means 1 is equal a minus 3 times b plus c. This is my second equation. Finally the constants. Here there is no constants. Here a and here I can write minus 3c, right. And I can write this, I can take this is my third equation. By solving these three equations I can find a, b and c, right. So how we've solved these three equations, I just multiply the first equation by 3, then add to the second equation. That means I can write 1 is equal 3a plus 3b plus a minus 3b plus c. That means we can write 1 is equal 4a plus c, right. I take this is my fourth equation. Now I solve fourth and third equations, right. For that I multiply the fourth equation by 3, then add to the third equation, right. 3 plus 0 is equal when 12a plus 3c plus a minus 3c, right. 3 is equal 13a, so a is equal 3 over 13. So those are the values of a and those are the values for a. So I can write the value of b from the first equation. B is equal minus a, that means minus 3 over 13. And using the third equation, C is equal A over 3, that means 3 over 3 times 13, that means 1 over 13. Those are the values of A, B and C for the final partial fraction question.